So this is kind of interesting. We got two straight lines, and we have to find a tangent of the smaller angle formed where the lines intersect. That sounds a little complicated, but basically they're telling us, unless the lines are perpendicular, there is one angle that's acute and one angle that's obtuse, and we have to find the acute one. See, they're telling us to find this angle. I mean, the tangent of this angle and not that. By the way, if this is alpha, this is 180 minus alpha, and let us recall that tangent of 180 minus alpha is the opposite of tangent alpha. This angle will have a positive tangent. This will be just the opposite. So sometimes you cannot really guess which one is the smaller angle because they're more like this, right? It's kind of hard to tell. Just guess. If the tangent that you get is positive, you guess right. If the tangent that you compute is negative, you guess wrong, and all you gotta do is multiply your answer by -1, because these two angles have opposite tangents, and this one has the positive. So that said, the two equations are 5x minus 2y equals 2 and x minus 5y equals 1. So if we solve for y in each equation, thereby bringing them into the slope-intercept form, we're going to get the following. The first one, we're going to get that y equals, add it there, 5x minus 2 over 2. So the first equation is y equals 5 over 2x minus 1. And the second one, 5y on the right-hand side is x minus 1. So we get y equals x minus 1 over 5, or y equals 1 over 5 x minus 1 over 5. Now here comes the other thing. These are completely irrelevant data. The y-intercept is switching a line vertically up and down, but they're all parallel to each other. And so it doesn't matter which two. These two will have the same angle as these two. So let us replace these two lines with these two, just to make life easier. The angle is the same. I'll draw a picture to verify that. So 5 over 2x minus 1 is here. 5 over 2x is here. And 1/5 x minus 1/5 looks like this. And the one that goes through the origin looks like that. And so what we're saying is that this angle is what we're interested in, but that's the same as this angle. So why not work there? So we're basically going to find the exact value of the tangent of the smaller angle formed by these two lines, not those two. Same thing. So what we know is that tangent of, so this here is y equals 1 over 5x, and this here is y equals 5 over 2x. Now, what is the slope? The slope is the tangent of the angle that is formed between the line and the positive part of the x-axis. This here is a 1 over 5. We could say this is 5, this is 1. And so this angle is, let's call this alpha. So tangent alpha is 1 over 5. And then beta is this. And really what we are asked to find is the tangent of the difference. See? So all we got to do is, given tangent alpha and tangent beta, find the exact value of tangent of beta minus alpha. So tangent of beta minus alpha is tangent beta minus tangent alpha divided by 1 plus their product. And now we just substitute the numbers. Tangent beta is 5 over 2. Tangent alpha is 1 over 5. And that's true in the numerator as well. And now we just let algebra take its course. 25 over 10. And this is 2 over 10. So the numerator is 23 over 10. The denominator, on the other hand, is 1 plus 5 over 10, which is 15 over 10. And to divide is to multiply by the reciprocal. So we get 23 over 15. I always get scared. So we get 23 over 15. And that should be the exact value of the tangent of the angle formed between those two lines. Thank you for watching.